Today we are going to learn about mastering try-catch in modern JavaScript. We'll explore how to implement effective try-catch blocks to prevent application crashes and enhance the robustness of your code. In this introductory block, we will set the stage for mastering try-catch in modern JavaScript. Error handling is a cornerstone of robust application development, ensuring that unexpected situations don't lead to application failures. By mastering try-catch, you can create code that gracefully handles errors, preserving user experience and application stability. We'll start by briefly reviewing the basic syntax of try-catch in JavaScript, which involves a try block to contain code that might throw an error, and a catch block to handle the error if it occurs. This video will delve into advanced techniques and common pitfalls, offering insights into using finally blocks for cleanup, handling specific error types, and integrating with async/await. Whether you're refining your error handling skills or looking to prevent application crashes, this video is designed to elevate your understanding of try-catch in JavaScript. Let's dive deeper into the syntax of try-catch. The try block allows you to execute code that might throw an error. If an error is thrown, the catch block catches it, preventing the application from crashing. This basic structure is crucial for managing errors effectively. In practice, you might encounter code where multiple errors can occur. While the basic syntax is straightforward, handling multiple potential errors requires a more nuanced approach. Typically, the catch block can be used to handle a variety of error types, with custom logic based on the error's properties. For example, you can inspect the error's name or message to determine the appropriate response. Additionally, the catch block can be omitted if you only need a finally block. This flexibility allows you to tailor error handling to the specific needs of your application. Throughout this video, we'll examine real-world examples that showcase the versatility and power of try-catch in JavaScript. While try-catch is a powerful tool, it can be misused if not applied correctly. One common pitfall is using overly broad catch blocks that catch all exceptions, including ones you might not intend to handle. This can lead to silent failures where errors go unnoticed. To avoid this, it's important to be specific about which errors you want to catch and how you plan to handle them. Another issue is misunderstanding how error propagation works. Errors can propagate up the call stack, meaning that if not caught, they might be handled in an unexpected part of your application. Misuse of try-catch can also affect performance, especially if used excessively or in performance-critical code paths. The key is to use try-catch judiciously, focusing on areas where errors are likely and handling them in a way that maintains application stability. We'll discuss strategies for effective error handling, emphasizing the importance of logging errors for later analysis and debugging. By understanding these common pitfalls, you can avoid them and implement try-catch blocks that enhance, rather than hinder, your application's robustness. The finally block in a try-catch statement is designed to execute code after the try and catch blocks, regardless of whether an error occurred. This makes it ideal for cleanup operations, such as closing files or network connections, releasing resources, or resetting application state. The finally block ensures that these important operations are completed, even if an error interrupts the normal flow of execution. A practical example would be ensuring that a database connection is closed after a transaction, whether the transaction succeeded or failed. While the finally block is optional, it can greatly enhance the reliability of your code by ensuring certain actions are always performed. Best practices for using finally include only placing code that must execute regardless of error conditions, and avoiding code that could throw exceptions itself. This block should be used to maintain a consistent application state, contributing to the overall robustness and reliability of your application.
Handling specific error types in your application allows for more targeted and effective error management. JavaScript provides the error object, which can be extended to create custom error classes. By differentiating between error types, you can implement logic that responds appropriately to each error. For instance, you might have a network error class for handling connectivity issues, while another class handles data validation errors. Creating custom error classes involves extending the built-in error class and adding additional properties or methods that provide more context about the error. This can be particularly useful for debugging and logging, as it allows you to capture and relay more detailed information about the circumstances that led to the error. Additionally, enhancing error messages with contextual details can significantly improve the debugging process, making it easier to identify and resolve issues. By managing specific error types effectively, you can improve the resilience and user experience of your application. Asynchronous programming in JavaScript is made simpler with async/await, allowing you to write asynchronous code in a more synchronous manner. However, integrating try-catch with async/await requires special attention. When working with promises, errors may occur when a promise is rejected. By wrapping the await expression in a try block, you can handle these errors using a catch block. This is particularly useful in functions marked with the async keyword, where you can use try-catch to manage errors within the asynchronous flow. Another important aspect is handling promise rejections, which can lead to unhandled promise rejection warnings if not properly managed. By using try-catch, you can catch promise rejections and handle them gracefully, ensuring that your application remains stable and responsive. We'll explore examples of integrating try-catch with async/await, demonstrating how to effectively manage errors in asynchronous operations.
Error logging is an essential practice in modern application development, providing insights into the health and performance of your application. Effective error logging involves capturing and recording error information, such as error messages, stack traces, and contextual data. This information can be invaluable for debugging and understanding the root causes of issues. To implement error logging, you can use built-in JavaScript methods like console.error or leverage third-party tools and services designed for logging. Enhancing logs with additional context, such as user actions or application state at the time of the error, can significantly improve their usefulness. However, it's important to avoid overloading logs with excessive data, which can make them difficult to analyze. By adopting best practices for error logging, you can create a robust system for monitoring and maintaining your application's health, enabling you to quickly identify and resolve issues as they arise. While try-catch is a powerful tool for error handling, it can have performance implications if used improperly. The presence of try-catch blocks can introduce overhead, especially if they are used excessively or in performance-critical code paths. To minimize the impact on performance, it's important to use try-catch judiciously, focusing on areas where errors are likely to occur and need to be managed explicitly. Optimizing error handling code involves writing efficient try-catch blocks and minimizing the amount of code within the try block itself. This can help reduce the potential performance impact. Balancing robustness and speed is key, as you want to ensure that your application is both responsive and capable of handling errors gracefully. Testing and profiling your application can help identify any performance bottlenecks related to try-catch usage, allowing you to make informed decisions about optimizing your error handling strategy.
To fully understand the power and flexibility of try-catch, let's explore some real-world examples and use cases. In web applications, try-catch is often used to handle errors related to network requests, such as fetching data from an API. By wrapping API calls in try-catch blocks, you can manage errors like network failures or unexpected response formats, providing users with meaningful feedback rather than allowing the application to crash. Another common use case is handling user input errors, where validation logic can throw exceptions if the input doesn't meet certain criteria. By using try-catch, you can catch these errors and provide users with helpful error messages, improving the overall user experience. We'll also look at case studies from real-world applications that demonstrate effective error handling strategies, highlighting how try-catch can be leveraged to create reliable and user-friendly software. These examples will provide valuable insights into how you can apply try-catch in your own projects to enhance application stability and user satisfaction. As we conclude this video on mastering try-catch in modern JavaScript, let's recap the key concepts we've covered. We've explored the syntax and structure of try-catch, common pitfalls and how to avoid them, the use of finally blocks for cleanup operations, handling specific error types, and integrating try-catch with async/await. Additionally, we've discussed best practices for error logging and the performance considerations associated with try-catch. Mastering try-catch is crucial for building robust applications that gracefully handle unexpected situations, ensuring a seamless user experience. As you continue to develop your skills in error handling, I encourage you to practice implementing try-catch blocks in your own projects, experimenting with different strategies and approaches. Thank you for joining us on this journey to mastering try-catch in modern JavaScript. We hope you found the information valuable and are inspired to apply these techniques to your own work. Until next time, keep coding and keep learning.